I am Arivalagan, Associate Professor, Department of Mechanical Engineering. I am working in Konganadu College of Engineering Technology. So this college is located in Totium. So today we are going to see the subject is Thermal Engineering 1. So announced 2017 regulation. So we are going to see the topic is a heat balance sheet for the IC engine. So heat balance sheet is a main parameter for analyzing the efficiency. Okay, so we are giving the heat input to the IC auto cycle, means we are giving the heat addition in the constant volume process. So our IC engine means it is a diesel cycle, so we are giving the heat supplied in constant pressure process. Okay, so in the constant pressure at the time of we are giving the heat input in the IC engine. Okay, so in that we are giving the heat supplied where all the heat will be used and where all the we are losing the heat. Okay, so here in this topic we are to analyzing the heat balance sheet. So the four parameter we are going to analyze. So heat is converted into indicated power. So one of the topic. Another one is heat carried away cooling water, and third one heat carried away by the exhaust gases, and fourth one unaccounted heat losses. So the four category we are going to see the heat, how much it will be debited in the four categories. Okay, so one by one we are going to see the problem. So in this problem the given for the observation for the engine. Okay, so the given ambient temperature, fuel consumption, calorific value of the fuel, engine speed is given, mean effective pressure is given, net brake load, so how much load will be given to the engine. Next one, brake drum diameter and rope diameter. Next one, quantity of jacket cooling water. Okay, so next one, temperature entering the cooling water and leaving the cooling water. Okay, so here the entering the cooling water temperature 22 degrees Celsius. So the temperature of leaving of cooling water is 70 degrees Celsius. So heat will be gained from the engine. The water some of heat is absorbed from the engine to the leaving the cooling water. Okay, so next one, quantity of air as measured. So how much air will be measured in the 225 kilogram per hour. Okay, so next value is specific heat of exhaust gas. Okay, so the CP value is 1.005 kilojoule per kilogram Kelvin. Okay, next thing, exhaust gas temperature 405 degrees Celsius. So here we are going to solve that indicated power, brake power, mechanical efficiency, and finally we are going to draw the heat balance sheet. Okay, so these are the given data. Already we are known that diameter of the piston is 0.3 meter, and length of the stroke is 0.45 meter. Okay, so temperature, mass of the fuel, mass of air, mass of water, CV values, and engine RPM, mean effective pressure, load, and diameter of the brake drum, and diameter of the rope, and the mass of water. There is at initial temperature and exit temperature of cooling water. So next gas term, I made that mg equal to 225 kilojoule per kilogram per hour, and CV value is 1.005, and temperature is, I would say, exhaust gas temperature 405 degrees Celsius. Okay, so first we are going to find the values indicated power. There is a abbreviation is IP. Okay, the formula for indicated power. So first one, we are multiplying to the mean effective pressure into length of the stroke into area of the cylinder into speed of the uh, piston, and K values for the how much cylinder we are using. Okay, so the K is how much cylinder we are using the engine. Okay, so mean effective pressure is given for this problem 600, and L is given, that is the stroke length, the 0.45 into area. How to find is a cylindrical shape, so the diameter for a cylinder is 0.3 meter. Okay, the formula for finding the area, pi by 4 into d square. Okay, so next one, the 2.5 means that is a n values. Okay, that is the RPM. So RPM for given this problem, so into 1 is the number of cylinder. Okay, so multiplying the all values, so we are getting the value 47.71 kilowatt. This is the indicated power. Okay, so next one, brake power, that is a shortly we are noted, that is a BP. Okay, so the formula is 2 pi into n into WR. Okay, so 2 pi into n means that is a RPM, that is the speed of the piston or speed of the engine. Okay, so W is the load, how much load we are given to the engine. Okay, so 1 kilonewton. Okay, next thing, that is R. R is the diameter. R is nothing but diameter, capital D plus smaller d divided by 2. What is D? Capital D and smaller d. So capital D is the breakdown diameter, smaller d means rope diameter. Okay, so our capital D is the 2 and smaller d is the 0.02 meter. Okay, divided by 2. Okay, so n is the 5 or PS into W is 1 kilonewton into R value. So we are multiplying this value, finally we are getting 31.73 kilowatt. This is a brake power. Okay, next one, mechanical efficiency. Okay, so mechanical efficiency formula is brake power divided by indicated power. So our engine, we are getting the efficiency is 66.51%. Okay, so remaining heat will be liberated in the cooling medium or exhaust gases or unaccounted losses. So then only we are achieving, we are reducing that liberating temperature means, so we are reducing the exhaust gases or cooling for water. So it will be reduced means, so our mechanical efficiency will be increased. Okay, so then we are going to solve the heat supplied. Okay, so how much heat will be given to the engine. So how to we are giving the heat supplied to the engine. We are burning the fuel in the cylinder. So in this fuel producing the heat. Okay, so we have to know the how much fuel we are burned, and the calorific value of the fuel is known. Okay, so this is the mass of fuel into calorific value. So our mass of fuel is 11 kilogram per hour. Okay, per hour we are using 11 kg of fuel is used. Okay, so at the CV value of fuel is 42,000. Okay, 42,000 kilojoule per kilogram, right? So we are multiplying the both values, 11 into 42,000, that equal to the 46. So the 46,000 kilojoule per kilo hours we are giving the heat supplied. Okay, so next we are going to solve that where are all the heat will be liberated. So heat supplied is we are point out. So next one, heat carried away by the cooling water. So okay, we are giving the cooling water for liberating the heat. Okay, so here the formula is QW equal to mass of water into CP value of the water into temperature difference. Okay, so temperature difference means temperature of the cooling water inlet, and T2 means temperature leaving the water. Okay, so the T1 and T2 is given, or we are observing the engine. Okay, is the value is we are finding that heat of we are heat we are losing into the cooling water. Okay, so next one, there is a we are find the value is in percentage. Okay, so in percentage of heat liberated in the water is 25.75 percentage we are liberating the heat in the cooling water. Next we are going to find the heat carried away by the exhaust gas. That is the same formula for finding the heat carried away by exhaust gases. So here we are know that mg value, cg value, and temperature difference. Okay, so here we are finding the values heat carried away by the exhaust gas, that is the 18.75 percentage we are liberating the heat in into the exhaust gas. Okay, so next one, indicated power. Okay, so indicated power we are getting the percentage, already we are finding the indicated power. Okay, so from the indicated power how much heat will be we are used. Okay, so 37.18 percentage we are using that indicated power. So this is the useful heat we are converting the work done. Okay, so next one, unaccounted losses. So how to find the unaccounted losses? So we are we are subtracting from the liberating heat minus and to the heat supplied. Okay, so where are all we are liberating the heat? So cooling water and exhaust gases and unaccounted losses. So sorry, indicated power. Okay, so from the subtracting we are getting the values 84,694.1812 kilojoule per hours. So in this term we are calculating the percentage. Okay, unaccounted losses 18.33 percentage we are liberating the heat from the unaccounted losses. So these are the values we are draw the heat balance sheet. Okay, so first one, how to find the how to draw the heat balance sheet. So two categories are we are taking the heat